So as we try to understand how to design a simulation, we really need to understand what's the context, what's the learning situation that's actually going on during the simulation. And one of the ways we can do that is understanding more about just what's the natural learning processes that we use as human beings every day. So if we take a person, take our little stick figure here, and some type of system, this could be biological, mechanical, doesn't really matter what it is, but it's dynamic in some way. And as we're observing that system, we're making inferences about how it works, understanding different trends, trying to understand how different pieces relate to one another, what something is. And as we're doing that, we are, in our own way, creating our own little mental model of how this thing works. We may even go as far as to begin to experiment with it. So if I do such and such, then this happens. We're forming these little if-then-else rules or algorithms in our mind. And this is an important part because it starts to fill in some of the gaps that we have with that mental model. And of course, this is just how we learn every day. As we go into the world, we push on the world pushes back, and we're constantly learning how things work. This, of course, takes some time. So one of the things we try to do to accelerate our learning is to bring in some type of an expert, somebody who already understands how the system works. And so now, as they're observing the system, they can help interpret, to help the learner understand what's actually going on, what things are, why certain things work the way that they work. They can also manipulate the system and help the learner identify things they may not have been able to on their own. And this helps to build a more complete and comprehensive mental model of how things are happening. The learner, of course, has this opportunity to ask questions, to fill in some of these blanks. Of course, this is the apprenticeship model. It's a method of instruction that's been used for thousands of years and is highly effective. So in designing a simulation, what we're really trying to do is to replicate this model to some degree by simulating the system, giving the learner something that they can observe and interact with, as well as having some type of instructional element that can help with the observations, the interpretation, can make changes, can do demonstration, and to some degree, depending upon the fidelity of what you're using, to be able to ask questions to understand more about how it works.